So to continue with our discussion of intercepts in section 4.3, how do we find the x or the y intercept from an equation that hasn't been graphed yet? So looking at the graph, it would be easy to see where it's crossing. Well, let's think about this. Did we notice that when there was an x-intercept, the y equaled 0, and when there is a y-intercept, the x equaled 0? So that kind of gives us a clue as to what we're going to do with these equations to find our intercepts. So if we're trying to find the y-intercept, we need to let x equal 0, because anytime a line crosses the y-axis, it's the x of that coordinate will always equal 0. So what do we need to do with our equations here? So if we look, I'm going to go ahead and rewrite this equation and just substitute the x for a 0. So we've done that before. We can do that. So I'll come over here. Y equals 3 times 0 plus 2. So again, we're trying to find our y-intercept, so we're letting x equal 0. So 3 times 0 just equals 0. So that term can just be canceled out because 0 plus 2 just equals 2. So our y-intercept will just be 2. Now, because an intercept is a coordinate, we realize that this right here represents a horizontal line. So whenever we're creating the coordinate for the y-intercept, we need to go ahead and write it in our intercept form. So y equals 2 is an actual equation. We're looking for a coordinate. So remember, x equals 0, so y would equal 2. So this is the coordinate for our y-intercept. So we can do the same thing with this one. We're just going to go ahead and substitute the x for 0 to find our y-intercept. So y equals -2 times 0. Again, that term, -2 times 0, is just going to equal 0. So when x equals 0, y equals -1. So our coordinate for the y-intercept would be 0, -1. So that was pretty simple, right? We found our y-intercept. How do we find our x-intercept? Well, this one's going to require a little bit more work because we're going to have to get the x by itself in the end. But the opposite is going to be true, so vice versa. Instead of letting x equal 0, we're going to go ahead and rewrite this equation and let y equal 0 now. So I'm going to go ahead and do that. And I have the orange marker. So we're just going to do 0, equals 3x plus 2. And rewrite this one, 0 equals -2x minus 1. So all we did was substitute the y for 0. Now from here, we just need to go ahead and get x by itself so we can see what x equals. So we've done this in other chapters, especially we worked with our algebraic properties of equality. We worked with that so many times in chapter 2. So we should be really good with that by now. So the first thing we need to do, we're going to subtract 2 from both sides. So subtract 2 from both sides. So this equation would then look like -2 equals 3x. And what do we have to do to get x by itself? Well, we have to divide by 3 on both sides. So our coordinate, our x equals a -2/3. And what did y equal? Well, we substituted y with a 0, so y would be 0. So this would be our x-intercept. So we'll practice it with this one. Again, we have to use our properties of equality. We'll add 1 to both sides. So these will cancel out. We can rewrite this equation as 1 equals -2x. And we need to get the x by itself. So this time we're going to divide by a -2 on both sides. The -2's on the right will cancel out, leaving us with just the x. So now we have our x-intercept. Our x-intercept will be a -1/2. And again, we substituted the y with a 0. So our coordinate would be -1/2, 0. So we just want to remember, When we're trying to find the x and the y-intercepts of a linear equation, all we have to do is set y equal to 0 to find the x-intercept, set x to 0 to find the y-intercept.